So let us discuss the k nearest neighbors. What is k nearest neighbors and why we need this? Another algorithm, KNN is just another algorithm for the classification and the regression task. But majorly it is used for the imputation task. Let's say we have some missing values in our data set and we cannot drop the entire column or entire feature. So we use the KNN imputation for this. How we use it? Let us explore. So KNN works on proximity principle, assuming similar data points are closer in the d-dimensional space. So let's assume that we have captured some shapes in d dimensions, where here my dimension d is 3, and we have some square, we have some circle, and we have some triangle. There are three different types of classes present in my data set. So for a square, number of sides is 4, number of corners is 4, and angles formed inside the square is 4. For a circle, number of sides 0, corners 0, and angles forms are infinite. For triangle, number of sides 3, number of corners 3, and angle formed are also 3. So there is a similarity between the triangle and the square, right? So they will lie closer in space. Let's say square and triangle, they are not similar, actually exactly similar, but they lie closer in space, and triangle and circle are farther away. So triangle and circle are farther away because they are not same. So this is the exact proximity principle that KNN uses. So the similar shapes are closer in space. So if let's say we have to impute some values, missing values for our data set, how do we impute it? So let's say we compute the distances between all the data points to the missing data point. Let's say it is a P. Q is my data point X, for which I want to find the missing value. Let's say here is my question mark. This is my ith row and jth column. So I neglect the entire row, entire column and feature, and compute this distance. So I just compute the distance with the every other feature. So the ith row, I want to compute the distance of the ith row to every other row, right? But I'll not include the jth column in the computation, and I'll compute the distance. So after getting the distances, I'll sort the distances in ascending order and pick the nearest neighbors. So let's say we have picked 3 neighbors, and out of the 3 neighbors picked, I'll do the either for a classification task, I'll do a majority voting. So let's say if I want to predict a class, let's say whether it's a square, it's a circle, or it's a triangle. So if my nearest neighbors have voted 2 for circle, 2 for square, 1 for circle, and 0 for triangle, so I'll go with the square. For a classification task, like regression task, like let's say number of angles formed are, let's say 4, and this is also triangle as 3, so I'll take the 4 plus 4 plus 3, but it doesn't make sense to take 3 here. Let's say 4 and 4 is 4 plus 4, it would be 3, so it would be 4 only. Let's say we have 2 squares and 1 circle, right? So for 2 squares, I'll take as infinity. It will screw up my example because it would be infinity then. So I'll take as infinity. Here infinity is just a toy example. Actually it would be a real number, but here I'm getting infinity just to explain, just to do that. This is not a real, or the mean value will take the average and mean, right? So this is how we can use the KNN for the missing value and also for the classification and regression tasks. Now, what are the nuances of KNN? So, the KNN doesn't rely upon the gradient descent or any algorithm. It is just simple statistics where we have to compute the distance and pick the nearest neighbors and do the prediction, final prediction for the target. So, no training required as it is based on statistics by a simple formula. Expensive calculation at infinite time when dealing with millions of rows. So it is very expensive to use in production as it needs to calculate the distances between each and every row. When we have millions of rows, it would be much slower. So it would be very slow at inference. Right? Sensitive to scale of features, standardized before use. So let's say we have some feature, dominant feature, let's say where the scale is 10,000, and we have some feature where scale is between 10 to 50. So the distance will go in the favor of this, because the difference between this feature would be higher than the difference between this feature. So this feature will entirely drive the prediction. So we don't want to happen. We want every feature should contribute equally, so that my final prediction is a correct reflection of the this. It can find the correct neighbors, right? So we should standardize the scale before using KNN. Now we have to choose K. So let's say we have K is an hyperparameter. So if we select a value of K very small, so it would be overfitting. Let's say we just rely on let's say one neighbor. So my decision boundary would look like something. It would be very complex, like this. It will try to fit to just one neighbor. But if I select a value very high, let's say 10 or 20, whatever, a number very high depending upon the data set, so K should be less than n, right? So if the value of K is very high, then it would be just a simple average of the selected neighbors. It would not represent anything, right? It also depends upon the balance between the data, how much data we have, uh, how much data we have, is it balanced or not. So we have to choose K accordingly. So that's why this is an hyperparameter. And generally if we pick a too small value of K, it would be a complex overfitting. And if we pick a very high value of K, it would be, the decision boundary would be too simple, and it would be an underfitting scenario. So what is the time complexity of KNN? KNN and the training time is O of 1. Why? Because it just stores everything into the memory. So there is no training happening at the training time, which is also the problem where it is using the lazy learner approach. So everything is being done at the inference time. So the inference time, the complexity of the KNN is n cross d. This is for the calculating the distances, this is for sorting, and this is for selecting K values. And weighted KNN, then we also have weighted KNN. This is useful for imbalanced dataset, which I have already mentioned. Just to I enjoy writing. For imbalanced dataset in classification task, prediction favors the majority class. So let's say we have picked 5 neighbors, but out of 5 neighbors, three class are from majority class and two are from minority. So the majority takes all and minority is left with nothing, as this is the exact real world scenario. Majority takes all, minority left with nothing, no matter the characteristics, the skills and whatever. You are left with nothing. So we use a formula, weight equals to 1 upon distance. So the let's say if our distance is less, the weightage would be high, and if the distance is high, the weightage would be less, and we use the distance, the weightage to calculate the class. Let's say class 0 weightage and class 1 weightage. So let's say class weightage is 3.5 and class 1 weightage is 1.6. So we go with the class 0. No matter the number of samples here, we only want to know the distance, the weights, calculated weights, no matter the majority, minority, right? The closer points get more weightage than farther points. Yeah, so that's the entire point of weighted KNN. Now, what are the limitations of KNN? So KNN suffers from curse of dimensionality. So as in high dimensional space, all data points are equidistant from one another. So if the dimensions are very high, so every point is equally far from the every other point. So the mathematical breakdown of proximity. So no points lie closer to one another. Every point is far away, equally far away. So as algorithm predictive power decreases as dimension increases, because the proximity goes away, right? But at what number? There is no standard number, but let us have a general number. KNN dimensions limit, I don't know. 10,000. Lucene history 10242048, and there are number equidistance 500 to 100. Let's say 500 D, 500 to 100, 1000 D dimension. In order to make predictions, algorithm require entire dataset loaded in memory. Yeah, at the prediction time, the model needs the entire memory loaded. Entire dataset loaded into memory. Yeah. And KNN requires k to be k less than n. Yeah. So if k is not less than n, if so so let's say my number of samples are 10. If I pick the 5 neighbors, so it would just be the majority, right? So the simple majority wins. There is no local proximity or anything happening, so everything goes to the global neighborhood. Clear imbalance, class imbalance and majority class wins. So there should be a clear separation between the k and the number of samples. The number of samples should be much higher than the number of k. Or 10 to the power 5. There is no general rule for this, but if I can have this general rule for n k less than n. I'm choosing k is k should be square root of n. Okay, square root of n. Yeah, we can use k equals to square root of n. A general thumb rule, and there is also thumb rule of selecting odd value of k, odd value of k to for a majority task, right? For a classification task, we need to have a majority on one side. So odd value can help us there. Thank you.